Okay, good afternoon, class. So at this point, we're starting a new topic today, natural numbers and counting numbers. Okay, so that's your new reading. At this point, we handed out your booklets. I've also sent to the group the PDF version of this textbook. Okay. It's a very old textbook, but it deals with algebra and the geometry really well. And the idea is for you, or most of you, to do maths in grade 10, 11 and 12. So we're going to try and give you a solid foundation to algebra. Okay. It's a new topic. So firstly we're going to start with natural and counting numbers. This is something that you're familiar with. And then the next topic is going to be algebra. Okay. So from the booklet that I gave out today, this topic is not in that. Okay. This booklet starts from chapter 2. However, the PDF I've sent to the group, it's in there. Okay. So you'll see me giving a reference sometimes to this book opposed to what we copied. What we did there was we took all the exercises and I cut out the exercises and we made this booklet. Okay, you guys understand? However, in the group you have the PDF version of this textbook, the whole textbook. You guys understand? So your heading is chapter 1, natural numbers and counting numbers. Then I want you to classify. Then you got natural numbers, you write that down. Counting numbers, natural numbers, prime numbers, composite, and all of those. We'll talk about that shortly, okay? So write that down quickly. Guys finish? Huh? So at this point you have written natural numbers. Numbers are 1, 2, 3, 4, 5. What does that dots mean? What does that dots mean there? It comes after 5. It continues. Okay? And then counting numbers. Counting numbers starts with 0. It goes all 1, 2, 3, 4 all the way. As you can see, the dots indicate that it carries on forever. Okay. Then you wrote the definition for prime numbers. You guys write that? Okay. Prime numbers, that's the next thing I want you guys to write down. Prime numbers, you write the definition and the examples as well. Okay. You guys spoke about prime numbers last year already, not so? Okay, I think we dealt with prime numbers in the first term as well, not so? So some revision on prime numbers, factors, highest common factor. So at this point we're looking at prime numbers. The definition is all natural numbers that are only divisible by 1 and the number itself. So it's only divisible by number 1 and itself. So examples of prime numbers is 2, 3, 5, 7, 11, 13, 17, 19, 23. What is the next prime number? 25. Can 25 be a prime number? No. 29 would be the next prime number. Then 31 and so on. Composite numbers. Composite numbers, the definition is all the natural numbers that have more than 2 factors. For example, or i.e., all the numbers that are not prime numbers except 1. So the example of composite numbers is 2, 6, 8, 9, 10, 12, 14, 15, 16. What would the next composite number be? 18 and so on. You guys understand?
Yes, sir.
The number 1 is neither prime nor composite. And you can write this, you can draw the diagram that follows. As you can see, it clearly states 1 is neither prime nor composite. And that is your set of natural numbers. Okay, just draw this freehand. Thereafter, you're looking at factors. Okay. Sorry? The diagram. Okay. You guys got the diagram? Right. So basically what follows from there is, you don't need to write this now down, is factors. We spoke about factors when we did the preparation for high school, not so? From that other book we spoke about factors, we spoke about multiples, we spoke about the highest common factor, the lowest common multiple. Not so? We spoke, I don't think we really spoke about products of its prime factors, no? Do you guys remember that? No. So that's one thing we have to look at there. Okay, so if you're looking at factors, factors of 6 is 1, 2, 3, 6. Okay? All these numbers that divide into 6 exactly, or is divisible by 6. Okay? Factors of 24 is 1, 2, 3, 6, 4, 8, 12, and 24. Prime factors of 24. Now, prime factors of 24 is prime numbers that are also factors of 24. Like 5. 5 is a prime number, not so. But is 5 divisible by 24? No. No. Is 24 divisible by 5? No. So, although 5 is a prime factor, it's not a prime factor of 24. Because I can't divide into 24 without remainder. Make sense? Right. Composite factors of 24 is 4, 6, 8, 12, 24. to express 24 as products of its prime factors. Now this we haven't done yet. No? So what we do is we say 24. What is the smallest prime factor that goes into 24? 2. Prime number is 2. 2 goes into 24 how many times? 12 times. But number goes into 12 without remaining. Smallest prime number? 2. So we do 2 until 2 can't go any longer. So 2 goes into 12? 6 times. So 2 goes again. 2 goes how many times? 3 times. 3 goes? Now 2 can't go any longer. Now I try 3. 3 goes? 1. So therefore 24 can be written as 2 times 2 times 2. There are 3 2's times 3. 3 2's will give you 2 cubed times 3. So 24 can be written as 2 cubed times 3. People, you guys understand? Any confusion there? No. Then the highest common factor, we work out factors of 12 and factors of 30, and then the biggest number, the highest common factor is going to be 60. Multiples, you know what multiples are? Multiples of 66, 12, 18, 24, 30, 36 and so on. The lowest common multiple of 6 and 16, you find the multiples of 6 and then the multiples of 16. 16's multiple is 16, 32, 48. So the lowest number, or the smallest number that is in both sets is 48. So therefore 48 is your LCM. Okay? Squares, we spoke about this extensively. Okay, I'm not going to bore you with that. Square, square roots, cubes, cube roots, we've done that. Not so? Alright. So this is something I need to touch on is writing, or this we can look at rather tomorrow, okay? Otherwise we're going to do too many new things at once. Okay, so what I want you guys to do is now to go to page 7 from the PDF on your phone or on your tablet. We're going to look at, for homework I want you guys to do number 1 to 10. We're going to start with it now, but we're just going to look at 1 or 2 examples dealing with products of its prime factors. Okay, so it's 1 to 10, and then you do number 14, the odd numbers. Numbers 1 to 10, and then number 14, the odd numbers. Okay, you guys understand what to do? But before I give you a chance to do that, we're going to write a couple of numbers in products of its prime factors. Is that okay? The number we are looking at is 2,916. 2,916. The question is to write 2,916 as products of its prime factors. So write that down first. Some says write 2,960 as products of its prime factors. Products of its prime factors.
So we're supposed to do that number, products of its prime factors.
So we're going to do this one first together and then we'll take it from there. Okay. So what is the smallest prime? You always go with the smallest prime number.
2.
So 2. So divide that number by 2 quickly. Then you write that answer next to it. Or below 2190. You give everybody a chance, okay? You all know how to divide that, no? So 2,916 divided by 2 is going to give you 1,453. 58. Okay? So what number goes into that now? Again 2. So divide 2. So 2 goes 720. Can 2 go again? No. So what do we try now? So try 3. Till 3 can't go any longer. Okay, so 3 goes how many times? 3 goes 81. 3 goes 27. 3 goes 9. 3 goes 3. 3 goes in there. To end off, there will always be a 1 in the last column. Okay? Are you all okay with that? So in other words, 2,916 can be written as 2 times 2 times 6 threes. 1, 2, 3, 4, 5, 6. So in other words, that can be written as 2 to the exponent. How many 2's are there? 2. Times 3 to the exponent. 6. So 2,916 can be written as 2 cubed times 2 squared times 3 to the exponent 6. You will understand? As we do another one. $5,184. 5,184. Question is to write 5,184 as products of its prime factors. Okay. Okay, so what's the prime number that goes into here? 2. 2 goes 2,592. Did you all get that? Okay. What's in the what number do we divide it by? 2 again. 2 goes 1, 2, 9, 6. Okay. Then 2 again. Goes 6, 4, 8. You all get there already? No. Who's at this point already? I'll give the rest of you a minute to catch up. Okay, 2 goes how many times? 320. Then 2 goes 162. Then 2 goes 81. Okay, you guys got it? Okay. I'll give you a chance now to complete it and then write it as products of its prime factors. Alright, so 3 goes into 81 how many times? 27. 3 goes 9 times. 3 goes 3 times. 3 goes. So as you can see, there's a 1 here at the bottom. So I know that we have stopped. So 5,184 can be written as 2 times. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And how many 3's? 4 3's. Yes?
Is it okay if I said 9, or does it have to be 3?
Is 9 a prime number?
No.
No. So the question was to write it as products of its prime factors. And since 9 is not prime, we now consider it. Okay. So that's going to give you 2 to the exponent. 1, 2, 3, 4, 5, 6. Multiplied by 3 to the exponent. 1, 2, 3. You guys understand? Do another one. Okay.
So is this called the ladder method?
This is the ladder method. You did it already?
Yes.
Oh, okay. So now, what happened? So, who did it last year? All of you. Okay. So basically, what happens is that if they ask you to use, if this was the sum, let's say the sum was what's the square root of 2,916. So in other words, it will be the square root of 2,916 is equal to the square root of 2 squared times 3 to the exponent 6. Not so. Okay? I'd rather take this out here, I don't want to confuse you. No? It shouldn't belong there. Okay. So, what is the square root of 4? 2. What's the square root of 9? 3. So, what's the square root of 2 squared? What is 2 squared? 4. Square root of 4? 2. What's the square root of 3 squared? The 3 squared is 9. Square root of 9 is 3. So what's the square root of 3 squared? 3. What's the square root of 64? 8. What's the square root of 8 squared? 8. Can you see the link, people? So what we do is we say, okay, the square root cancels the square. Not so. Or we can say 2 divided by 2 is 1. 2 divided by 2 is 1. You guys understand? So if I go back to 64 and we say, okay, square root of 64 is actually I want to do 16. 16. Square root of 16 is? No? But we say the square root of 4 squared is? What's the square root of 4 squared? What? 4. So 16 can also be written as 2 to the exponent? 2 to the exponent? 4. Are you all okay with that? How do we get 2 to the 4? It was 16. 2 goes into 16, 8 times. 2 goes into 8, 4 times. 2 goes into 4, 2 times. 2 goes into 2, once. So 16 can be written as 2 to the 4. Not so? Right. So what is the square root of 2 to the 4? 2 to the 4 is 16 and the square root of 16 is 4. So the answer is 4, yes. But if you're looking at this 2 here, I can say that's going to be 2. 4 divided by 2. What's 4 divided by 2? 2. So that is 2 squared. And what is 2 squared? So what you should be picking up here is that we're going to divide the exponent by the root number to simplify it. Can you see that? So if you have, for argument's sake, let's break another one. If you got the square root of 81 is 9. But the square root of 9 squared is? The square root of 9 squared? 9. 9. So what? If you're looking at 81, 81 can also be written as what? 81 can be written as 3 to the 4. So the square root of 3 to the power 4 can be written as 3 to the 4 divided by 2. If there's no number, there's a 2 here. Not so? And 4 divided by 2 is 2. And 3 squared is? Can you see that, people? So what we do is we take whatever the root is and we divide it by that number. That's all we're doing. Okay. Yes, Michael? That's it. What can it be? 3. Cube root. Since if there's nothing written there, we know there's a 2. Because the first root of anything is not going to change anything. Okay, that's why you never see the first. Okay. So if I put that into play now, and we are asked to simplify this here. What would this be? This should be 2 to the exponent 2 over 2. Not so. Times 3 6 over 2. Then it will be 2. What's 2 divided by 2? Times 3 6 divided by 2? 3. How do you get 2? What is 6 divided by 2? 3. So 2 remains 2. What is 3 cubed? 3 times 3 times 3 is? 27. 2 times 27? So the square root of, and we can test it. Okay, you're not allowed to use a calculator in your exam. But we can say, okay, the square root of 2916 is 54. Can you see, people? So let's put that into play in the next one. What would the square root of, if the sum was, what is the square root of 5184? The sum would normally read, by using products of its prime factors, determine the square root of 5184. So we said 5184 can be written as the square root of 2 to the exponent 6 times. So simplify that for me quickly, as I did in the previous sum. Guys, finish? Okay, so what will this be? 2 to the exponent 6 over 2 times 3 to the exponent 4 over 2. So it's 2. What's 6 divided by 2? 3. Times 3 to the exponent 2. What is 2 cubed? 2 times 2 times 2. 8 times 9. And 8 times 9 is 3. Square root of 5184. Who got that right? Blessing, where you got on?
I didn't divide by 2.
What did you do? Minus the 2.
No, I just did it the way I wanted.
The way you normally did it and you got it wrong. So please do not do what you normally do. Okay, you must follow the steps I showed you. Okay, behind this, what did you do? Sorry? Copy that. Well, okay, what did you do? Explain to me what.
I found 2, like 2 exponents, then after 2 is 6.
So you said 2 to the exponent 3.
2 to the exponent of 6.
And 2 to the exponent of 6 is 64. But where did I show you that? Did I show you that before? No? So do what I show you. It's for a reason I show it. You see, what if you had 2 to the 10 or 2 to the 12? Then you're going into thousands. You understand? So that is why we are applying this method. Okay. People, to the homework, please add number. I already gave you number 1 to 10, as well as 14, the odd numbers. Add number 15.1 to the homework as well. 15.1. And 15.3. 15.1 and 15.3. People, enjoy the rest of your day. Good afternoon, class. Go, friend. Go do your own thing. No?